In this video, we're going to look at accuracy and precision. And the best way to really think about accuracy and precision is through bullseyes. But before we do that, let's actually look at the definitions of accuracy and precision, as this is something that Gen Chem students often get wrong. Accuracy is just saying how close you are to the actual number, and precision is saying how close your measurements are. So if we're trying to aim for the center of the bullseye, and if we take 6 shots and all 6 shots are around the bullseye, we're accurate because we hit our mark, but we're also precise because everything is clustered together. While we take those 6 shots and they're all clustered together but not near the bullseye, well, we're not very accurate, but we're very precise in our shots. Now in this third bullseye, our shots are all scattered around the bullseye, so on average, if you take the average of these shots, we're actually on the bullseye, so we're high accuracy, but since our shots are so scattered, they have low precision. And lastly, we have this bullseye where all our shots are scattered and not near the actual target, so we say we have low accuracy and low precision. Now here we have 3 different students measuring out a lead block, and the lead block has a known mass of 10 grams. And what I want everybody to do is I want you to look at the data for these students A, B, and C. And the question is, which students do you think are accurate and which students do you think are precise? So I want you to pause the video and come up with those answers. Alright, so let's actually look at this data. If we look at student A, there are the 4 different measurements. And the blue is the actual weight, while this dotted line is the average of what they got. You can see student A is not accurate and not precise. They're not near the true mass and their data is all over the place. Now student B is precise. All their measurements are the same, but they're not accurate. They're not near the true amount. And for student C, we have that their measurements are near the actual weight and they're all clustered together. So student C is both precise and accurate. Now, when we're looking at people who aren't, or data sets rather, that aren't precise and accurate, we have different types of error that can go with them. The first type is random error, and that's shown by student A. And random error is just what the name says. You have equal probability of your measurements being either too high or too low. So there's some random error for student A. While student B has systematic error. That is when either your measurements are all high or all low in this case. And this could be due to the machine that they were using. It was improperly calculated. While random error is usually has to do with either the student doing something wrong, where maybe at trial 1 and 4 they didn't properly reset the machine to 0, or they weren't doing measurement techniques right, or they were pressing down. Who knows? But there's just randomness to it. While systematic error was they were probably doing the experiment right, but the machine they were using wasn't properly calculated. Alright, that's it for this video. See you in the next.